Okay, today we are doing Packet Tracer 5.2.2.3, Troubleshooting Single Area OSPF version 2. In this activity, you will troubleshoot OSPF routing issues using ping and show commands to identify errors in the network configuration. Then you will document the errors you discover and implement an appropriate solution. Finally, you will verify end-to-end connectivity is restored. So, let's start out with a show command on router 1. We're going to do show run, see what the running configuration looks like, and we're going to focus on the OSPF portion of it. So router OSPF with a process ID of 1, passive interface gig 00, it's pretty normal. Network 172.16.3.0, that's this network. Network 172.16.1.0, that's this network. And network 172.16.10.4 should be 192.168.10.4. So let's go into router OSPF 1, do a no network 172.16.10.4 0003 area 0 to remove that line, and then we're going to replace it with a network 192.168.10.4 0003 area 0. Enter. Okay, that brought us up to a third completion, so we'll copy the running config to the start config in case we have to power cycle anything. And let's do some more commands here. Do a show IP protocols. Okay, so this is router 10.1.1.1, so it took it from the loopback interface, loopback 0. Sees both of its neighbors. Okay, so let's do show IP OSPF interface. So gig 00 is up. 10.0.0.0 up. Hello 10 dead 40. Adjacent with neighbor 10.2.2.2, so that tells me this is 00.0.0. 00.0.1 is up. Line protocol up. Hello 10 dead 40. Okay. Let's move on to router 2, see what's going on with router 2. Okay, router SPF 1, passive interface gig 00, again that's the local area network there. 172.16.2.0, that's this network. 172.16.3.0, that's this network, and 192.168.10.8 is this network. That looks correct. We also have a static default route here through serial 010, which is this guy, and we are router OSPF 1, as is the case on router 1. So let's do show IP protocols. We see all our neighbors. That's good. One area in this router. Okay, let's check out router 3 real quick. Okay, router 3 is also router OSPF1. We are advertising 192.168.1.0, which is this network, 192.168.10.4, which is this network, and 192.168.10.8, which is this network. Oh, but look at this. We have an IP OSPF hello interval of 20 on serial 001, 192.168.10.10. So that's going to be this interface. So these two interfaces are likely not talking to each other. Let's see here. Show IP OSPF interface. And that was serial 001. Yep. Okay, so we're not showing any adjacencies here. Hello 20, dead 40. Usually your hello and your dead, generally your dead timer is 4 times as long as your hello timer, and they have to be the same on either end of the connection, otherwise you're not going to have that convergence. So let's go over to router 2 and look at serial 001. Serial 001 has a hello of 10 and a dead of 40, so just as it should be. So we're going to go back to router 3. We're going to go to serial 001. We're going to do a no IP OSPF dead interval 20. Let's see if that fixes it. No. Okay, so we're going to have to do, well, first let's write it, and then let's do clear IP OSPF process. Yes. Okay, I see that 001 did not do anything there. Are we... Okay, so let's just go ahead and do IP OSPF dead interval 10. Oh. That's why. I should be doing the hello interval, not the dead interval. So, no IP OSPF dead interval 10. No IP OSPF dead hello interval 20. There it is. We got our 67%. So that was another one of our problems. Okay. Now let's see. We've got clock rate 64,000 on 000, router 3. It's that one, and this is router 1001. I guess the DC interface, the DCE interface sets that. Must be automatic on the other end. Okay. So router 1. Let's just go ahead and ping. Let's see. Let's look a little deeper here. Let's do show IP OSPF. Try to ping the web server here. Destination host unreachable. Okay. Try it from PC2 to see if it's. We'll also try from PC3 as well, while PC2 does its thing. Okay, so PC2 can reach the web server. PC3 and PC1 cannot. So, okay, so here's why. I'm guessing. This is my guess. So PC2 can reach the web server because PC2 is attached directly to router 2 through this switch. But router 2 knows where the web server is, and even though router 2 has that default route in the default static route down here, it did not advertise it to the other two routers because it's not here in the network list, and it's not listed as default information originate. So let's go into router OSPF1. And let's do this one right here, default information originate. And there we are, 100% completion. So that's all you need to do for this one. Your teacher may require that you fill this out. I'm not sure. I don't think mine does. We'll find out. And thanks for watching, and good luck, everyone.